Hello there and welcome to Lower 6 Maths A-Level. This is the Applied Practice Paper I. Here we're working on question 6, a forces and vectors question. So a particle P is acted upon by three vectors, F1, F2 and F3, given by F1 is 6i minus 4j, F2 is minus 2 plus 9j, and F3 is ai plus bj newtons. Given that P is in equilibrium, find the value of A and B. Okay, so let's draw a diagram for this. So imagine you have a particle with three strings attached to it, and each string is pulling it in a different direction with a different force. So the first string is going to be pulling it 6i, so that's 6 to the right, and 4 minus 4j, so that's 4 down. So that's the first vector. Minus 2, so that's 2 to the left and 9j upwards, so that's going to be up here, 2 minus 2 plus 9j. And then F3 is going to be acting in some direction, maybe down here, not too sure, to balance out all these forces. So let's just draw it here. I don't quite know where it would be. So it would be AI plus B J. So what must happen here is that all of the I forces must balance out to make a 0, and all of the J forces up and down must balance out to make a 0 as well. So just looking at the I forces to start with, we're going to have A minus 2 plus 6 equals 0, because we don't want it moving left or right by anything, so these forces must all balance out. So what we must get here is A equals minus 4. Okay, so that will equate this out to 0, and on the J components what we need here is B plus 9 minus 4 equals 0, so B must therefore be minus 5. Okay, so what we needed to do here was we needed to create A and B such that all of these forces, when we add them together, gives us 0, because it said in the question here the keyword was it was in equilibrium. Okay, the force F2 is now removed, so we've got rid of this one now. The resultant of F1 and F3 is R. Now, don't get worried about this resultant word here, this just means add the two together. Find the magnitude of R. So let's do F1 add F3 first, because that's what resultant means. So this is going to be F1, which is 6i minus 4j. Add on the vector minus 4i minus 5j. So we just plugged these two values into the F3 force here. And what do we get? We get 2i minus 9, minus 9j. Okay, but it doesn't ask for the force of R. What we want is the magnitude of R. Now remember, magnitude is just a posh word for saying Pythagoras distance. So that's 2 minus 9, so it's effectively the distance along this line here, which is just a bit of Pythagoras. 2 squared plus 9 squared, that's the square root of 85, or 9.21 newtons. Okay, next part is to find the angle to the nearest 0.1 degrees that R makes with the I vector here. So I've already drawn my my R vector here. So what we need is this angle round from here to here that it makes with the I vector. Now the I vector, remember, is just moving right. So what we want is this angle here that it makes with the vector R and the I vector. Now in this case here, it's just going to be a simple case of right-angled trigonometry. So we've gone right by 2, remember, and down by 9. So on our right-angled triangle that we have here, we've got a base of 2 and a height of 9. So what we need to do to work out this angle here, it's going to be a tan type angle, so tan minus 1 of opposite over adjacent, so that's 9 over 2. So get your calculator out, tan minus 1 of 9 over 2 is 77.5. Okay, so that's all you need there. You just need some good diagrams. Then the word resultance just means add your two forces together, and the magnitude is just the distance of the total value of that force. A bit Pythagoras theorem to work that out. And when you're finding any angle between a vector and an I or a j, just imagine what that I or j vector is. If it was j, it'd be the whole angle round from here to here. Given that it was just I, it's just this smaller angle round from here to here. Okay, so that's 7 marks for that question.